This is a short tutorial on how to calculate area for functional skills tests. Now, unlike GCSE, we don't have to go into a lot of the shapes like hexagons, circles, we don't have to touch any of that. The main ones we have to do are irregular shapes, which are shapes that can be made up of multiple shapes, or squares and rectangles and triangles. They're the only shapes we need to worry about for now. So, we'll start off by looking at squares and rectangles. Now, bear with my drawing quickly as it will be freehand on a board here. But whilst we're working out the area, you'll tend to get a shape like this with dimensions around two sides of a square or rectangle. Now, hopefully in your actual test it'll be a little bit more accurate than this drawing, but still we can have a work through this. So, the area of a shape is all this space on the inside of it. Now, it's almost like trying to find the area of a room if you're putting down new carpet or something like that. So there's a very easy way to calculate the area of a square and rectangle, and that is length times by width. So in this we've got the width of the shape here, which is our 10 meters. So we've got 10 there. And the length of our shape is this one here, which is 8 meters. So we end up with 8 times 10. So 8 times 10 is equal to 80. Now, one thing we do have to look for when we're doing area is we've got 80 meters and then we have what we call squared after it. Now, we'll get this every time we do area. It might not be meters, but you'll always have a squared after it. Now, all that means is that you've times, in this case, meters by meters is equal to meters squared. So, like I say, it might not always be meters. You could have centimeters times centimeters is equal to centimeters squared, and so on. So, that's the main way of finding the area for a square or a rectangle. It'll always be the same. That is never going to change. So, we'll move on to looking at triangles now. So, if you're trying to work out the area of a triangle, you'll have a fairly basic triangle. Oops, neaten that up just a little bit. We'll have a fairly basic triangle, something along these lines. Say 15 meters across the bottom, and you'll have, if they're trying to find the area, you'll have a dotted line down the middle, or maybe just a solid line down the middle, with, again, just another dimension in there. Now this is the height of the triangle. One thing you've got to be careful of when we're trying to find the area of triangles is if you've got a measurement up the side like this. Because a lot of people will take this to be the height of the triangle. Because it's going at an angle up the side, it's not the height. The height will always be inside the triangle. So we can just forget about anything on the outside other than the base, which in our case is 15. So when we start trying to find the area, we start off very similar to how we did with the how we started with the squares and rectangles. But in this case, it's called base times height. Now, to be honest, this is exactly the same as length times width. The only difference is it's got different names because it's a triangle, not a square. That's the only difference. So, first of all, we'll look at the base, which in our case is here at 15. And our height, as we've already looked at, is 8. Now, if you're looking at this calculation thinking, well, I can't do that in my head, don't worry. With all functional skills tests, you're allowed a calculator, so feel free to use one. So that comes to 120. So again, remember, it's meters squared. Even though it's a triangle, it doesn't matter. You're still timesing meters by meters, which is still going to give you meters squared. Every time, it doesn't matter what shape it is, you'll always end with that. So this is the very start of how we do it. It's the first step. But what you're actually doing at the moment, in fact, let me use a different colour for this. What you're actually doing at the moment is working out the size of a square that will fit around this triangle. So currently we've got all this kind of space on the outside that we don't really need, and we need to get rid of that to work out the area of just the triangle. So the only thing that we need to do is to take our base time height measurement, which for us is 120 meters squared, and we just need to divide that by 2, which would give us 60. Oops, running out of space a little bit, but still 60 meters squared. And that's how we get rid of all this extra space here. And that's it for a triangle. Now, the last one we needed to look at was an irregular shape. Now, all an irregular shape means is that it's made up of multiple shapes. So one of our prime examples at the moment, something along these lines. Just neaten that up again. Have something along these lines, so you'll have 20 meters up here. So we'll go 20 meters again down this side. Go 12 across here. So we'll just go 10 meters and 10 meters. Now, if we were going to do the same thing, the same technique that we used with the square and rectangle by timesing length times width, which is 20 by 20, what we'd end up working out is all the space that's in here as well. So obviously this is not something we want to work out. So what we can do instead is to split this shape up into multiple shapes. So we could draw, say, an imaginary line across here, and now you've got two shapes, shape A and shape B. Both rectangles, and we know that we can work out the area for a rectangle. So what are we going to times together for shape A? Now we've got three sides that go around it completely. So we've got the 12 down here, we've got the 10 here, and we've also got the 20. But we can't use this 20 because it goes through both shapes. So that one we don't need. We can get rid of that one straight away. So now we're only left with these two sides. We've got 12 and 10. And we're going to do exactly the same method we did with the rectangles earlier. At 12 multiplied by 10. Like I say, if you need your calculator, feel free to come back to it. 12 multiplied by 10 is 120. So again, this is going to give us, and I'm running out of space a little bit here, 120, and don't forget your meters squared on the end of that. Then we can do the shape for B as well, same thing. So again, we know we can't use this one here because it goes through both shapes. What about this 8 though? Again, we can't use this one because it stops here, and you've got this big chunk here that's missing. So from that we know we're going to have to use the 20 up at the top and the 10 here. So exactly the same technique again. 20 times by 10. Bring that up. Which gives us 200. So what we've worked out here is the shape A has 120 meters squared and shape B has 200 meters squared. So to find out what all this is combined, We just need to then add them together. So again, bring up your calculator if you need it. So we've already got 200 up there. Add on your 120, and that shows us that the area of this irregular shape is 320 meters squared. And that's all there is to it. And this is the end of that short tutorial.